Okay, good morning. Today we'll discuss N and wave propagation subject. In this N and wave propagation, we discuss antenna and wave antenna and measurements topics. Okay, you can measure in this topic antenna and special application. Then why we are choosing in the radiation pattern in hexagonal shape, then what are the parameters to measure the what are the parameters to be measured in the measurement of antenna. So you can measure and gain, bandwidth, directivity. Those parameters can in the measure in this topic. Okay, next one. Antenna for special application, it include embedded antenna, plasma antenna, and ultra wideband antenna. Is used for mobile communication system and ground penetrating radar. Okay, this antennas terrestrial communication system used the frequency ranges of about terrestrial communication 200 megahertz to 60 gigahertz. Then modes of cellular telephone, modern cellular telephone system used from 1 gigahertz to about 17 gigahertz range. Okay, there are three models are available: non-adaptive base station, adaptive base station. Third one is antennas on mobile handsets. Okay, non-adaptive base station we are used for mobile switching center, then cell safe. Okay, in this mobile switching center you can use it for transmitter and receiver antenna. Then cell safe we are used hexagon safe. Okay, antenna measurement, you can measure the arrangements of radiation pattern measurement here used for transmitter and receiver antenna. The transmitter antenna to generate the transmitter oscillator, and the receiver antenna is receiving devices. In this transmitter antenna used primary, and receiver antenna used for secondary applications. Okay, can measure the antenna parameter using experimental setup. In this setup we are used primary antenna and secondary antenna. Primary antenna we are used for indicator, signal indicator, and fixed attenuator, and gain horn antenna. Okay, then receiver antenna, it is called secondary antenna. In this secondary antenna we are used for signal sources, then modulator and demodulator and power bridges. Okay, and these are the antenna radiation pattern measurement. Here used for radiation pattern measurement, the source antenna and the receiver antenna in the same direction, we can receive 100% maximum radiation pattern in the particular direction. Suppose if deviate from one to other, the radiation is reduced. Okay, this is the antenna measurement. We are used for power bridge method. The power level indicating device is used to check the stability of the transmitter. Okay, can measure power gain. Gamma B is equal to W2 divided by W1 in the decibel. Log of gamma B is equal to log omega 2 minus log omega 1 when case P1 not equal to P2. The power level is changed during the measurements. Suppose P1 is equal to P2, 10 log P1 divided by P2. Okay, then gamma power gain gamma B is equal to P1 divided by P2 is equal to omega 2 divided by omega 1 into P1 divided by P2. Then gamma B is equal to gamma B into P. Next one is we are used the antenna measurement with calibration method use two identical antenna, this arbitrary antenna. Okay, the calibration method also used for signal. Primary antenna is used indicator, signal indicator, receiver, detector, then an attenuator. Then receiver side can use the signal source, detector, modulator, then power bridges. Okay, in this calibration method, you can measure the radiation, that is omega r divided by omega t is equal to gamma naught lambda squared divided by 4 5 into gamma naught lambda squared divided by 4 5 into 1 divided by lambda squared r square. Okay, the finally you can get the gamma naught is equal to direct or indirect rays, or gamma naught is equal to 4 pi r divided by lambda f into omega r divided by omega t. That is where f is the propagation constant. Okay, impedance measurements. In this impedance measurement, we can calculate the Z value, that is Z is equal to V divided by I, where Z is the impedance, and in terms of resistive and reactive components. Okay. And Z is the impedance, and in terms of resistive and reactive components, resistive components Z is equal to R plus Jx. R is the reactive component, X is the reactive component of R is the resistive component, X is the reactive component. For in terms of angle, theta is equal to tan inverse of X by R. Using this fridge method, you can calculate the impedance value Z force equal to Z3 into Z1 divided by Z2. Then voltage standing wave ratio, you can calculate this method. You can calculate VSWR is equal to 1 plus mod of K divided by 1 minus mod of K. This is the voltage standing wave ratio calculation. Okay, thank you.